Greetings, and welcome to We Are Reading. My name is Eliwananda, and We Are Reading is two different things. So on the weekends, almost every single weekend, I do live stream sessions where we read books by Black authors, African authors, which I think are important to us as African people in particular, understanding our position in this world, understanding why we're in the situation that we're in and how we might be able to improve our situation as African people in this world. So that's every weekend we do those sessions, usually on Saturdays and Sundays at 9 p.m. UK time, which I think is 3 p.m. Eastern Standard Time in the United States. This is the start of a new series running concurrently with my weekend live streams. This is a new series that's tentatively titled We Are Reading Extra, but I'm also thinking of calling it We Are Reading STEM, STEM. And these are going to be videos where I'm going to be focusing on practical matters to do with science, technology, education, engineering and mathematics, but particularly science and particularly health, because I feel that when we're talking about politics, when we're talking about, culture, when we're talking about economic systems, social systems, and all this sort of kind of stuff, all of it exists in our bodies. All of it exists in our flesh, in our biology, in our genetics, even. And particularly when you're talking about things like systemic racism and these sorts of things, these are things which impact our bodies. And so it's really important for us as African people in particular to understand understand how our biology is impacted by the environment that we live in, and as much as possible on an individual level, I'd like to share knowledge and information that will be helpful for us on an individual level, for ourselves and for our families, but also information that will be useful for us to help us to kind of come together and to organize and to, help, organize and advocate for policies and policies and measures that will help us to improve our health, help us to improve our nutrition, help us to improve, the quality of life that we have across the world. But mainly I'll be focusing, I guess, on us in the diaspora. So without further ado, this is the beginning of a new series, as I say, and we are going to talk about vitamin D. So funnily enough, I made a video about vitamin D about 10 years ago now. And I was rewatching this video that I made. And in that video, one of the things I was saying, I made that video in 2013, I think it was, about vitamin D. Check it out, I'm a younger, bright-eyed, bushy-tailed Ellie. And anyway, in that video, I kept on saying that, I need to make a follow-up video to this where I'll go into a lot more detail and so on and so forth. Here I am 10 years later, and let's do this. So vitamin D, just a real top-line summary. In my studies on vitamin D, I'm seeing and learning that vitamin D is an extremely important thing. It's not even a molecule. It's much more than a molecule. But vitamin D is extremely critically important to human health. Really, really, really important. I'm actually flabbergasted as I've been reading about vitamin D. It's almost like I'm almost like, is this for real? Like, are these people just making stuff up? Because it has so many impacts on human health. It has so many connections with our well-being, physically, mental health, even all these kinds of things. And I thought, I need to get into this. I first started thinking about getting back into thinking about health and nutrition and these things because I was a couple of months ago in September, I was quite ill for a while. I was ill for about 3 or 4 weeks, and it really got me to realize and remember that actually I need to be taking control of my health. I can't just be out here just living any old regular life. I have to focus on my health. I have to understand what am I putting into my body. I have to understand how I'm living, the kind of life that I'm living, and what impact that is having on me. So yeah, that got me really studying. That got me really studying deeply, and I was looking at various things. But vitamin D kind of really stood out as something that I need to, I need to really get into, and really I'd like share, basically what I really want to share, what I've learned with you guys. So let's get into it. I've got some notes which I'm going to kind of be checking through as we go through. And the first thing I want to say is, like I hinted at briefly earlier on, vitamin D is much more than a molecule. Vitamin D, weirdly, strangely, like a lot of things, when you start to really study health and nutrition in particular, you find that things are a lot more complicated than they are kind of made out. So vitamin D technically isn't a single molecule or a single nutrient or anything like that. Vitamin D is actually consists of a family of compounds. So vitamin D is not a single thing. Vitamin D refers to, as far as I can tell, we'll look at this in a minute. Vitamin D refers to 7 or 8 different compounds, which are composite substances or composite organic substances, which fall under this umbrella of vitamin D. The way I've come to understand it, I've come to think about it, is that it's like a family, because all of these compounds kind of descend from one another in the main. So they start off in one form, and then they're converted into another form, and there's different varieties of that form, and then they're converted into another form. So vitamin D is like a family of compounds. Vitamin D is not a single thing, is the first important thing to point out. Vitamin D is a vitamin. What is a vitamin? Basic question. What's a vitamin? If someone asked you what is a vitamin, what would you say? Most of us, I would have said, before I started getting deep into these things, I would have said, yeah, vitamin is something that's good for you that you eat, really. And that's true. That is true. But to just be more specific, vitamin D is considered, this family of compounds that's called vitamin D is considered a vitamin for humans because it's essential to our being able to live. We can't live without vitamin D. But 2, we have to get it from outside. We cannot create it endogenously in our own bodies. And so my understanding is that is what qualifies something to be a vitamin. It's that it's essential for life, and it can't be created in the body. So in the case of vitamin D, we can get it from 2 places. One, we can get it from our diet. We can ingest it, we can eat it, consume it, and so on, or take it in supplement form, of course. But most of it comes from synthesis in the skin from the effects of UVB light. So we're going to come back to that in a minute. But in that sense, vitamin D is a vitamin because it's an essential nutrient that we can't create endogenously. However, vitamin D is also considered by many, it's also considered to be a hormone, a steroid hormone as well. And this is because it's considered a hormone because it circulates around the body, interacting with cells and altering the behavior of these cells. So that's what hormones do. They're secreted from glands and they go around and, have effects throughout the body. And it's considered also a steroid hormone because it's produced from cholesterol, interestingly. So it's also a hormone. Vitamin D, yes, it's a vitamin, strictly speaking, but vitamin D is also considered to be a steroid hormone. Interesting stuff. So let's talk about, where do we get vitamin D from? I mentioned that we can get it from our diet, but most vitamin D that we get in the human body, most of it comes from the skin. And to just read my notes here, it's estimated that around 80 to 90% of the vitamin D that we have in our system, in the human system, originates from the skin. So the synthesis or the creation of vitamin D starts with the oxidation of cholesterol to something called 7-dehydrocholesterol. 7-dehydrocholesterol. And then this 7-dehydrocholesterol is transported to the skin and is stored in the cell membranes. It's stored in the skin, basically, in the membranes of keratinocytes and fibroblasts, which are skin cells in the epidermis of the skin. In the skin, this 7-dehydrocholesterol is then impacted on by UVB lights, and it's photolized, is the technical term, is turned into something called pre-vitamin D. So that's one of the first of these many compounds of vitamin D is actually called pre-vitamin D. So this pre-vitamin D is then converted in the skin to vitamin D3, which is also called cholecalciferol. So this cholecalciferol, you can see from the name, chole is from the cholesterol, because it's made from cholesterol ultimately. And then calciferol, as we'll see later on, it refers to one of the main purposes of vitamin D in the body, which is related to calcium. But this thing is called cholecalciferol, also known as vitamin D3. This vitamin D3, which is one of the most important, the major forms of the major compounds which are part of the vitamin D family, enters into the bloodstream, and when it's in the bloodstream or the serum, it binds to a binding protein called vitamin D binding protein. And this vitamin D binding protein, you'll often see it written in the scientific literature. You'll see it just written as DBP, D, i.e. vitamin D, B for binding, and P for protein, vitamin D binding protein. So this is something that's very common for a lot of hormones. This happens also with testosterone and some of these other sex hormones. They have to be bound to a protein in order to circulate around the body. So vitamin D3, cholecalciferol, once it comes into the blood, is attached to a binding protein called vitamin D binding protein. And then that's how it kind of can move around in the blood. So that's the vitamin D that we get from the skin. There is another form of vitamin D which is called which comprises of around about 10 to 20% of the vitamin D that we have in our body. This form of vitamin D comes from food, and there are two forms that this can come in. First of all, we can get the same cholecalciferol or vitamin D from consuming foods, but that we can only get that from consuming animals. Here we're talking about things like, I think, oily fish in particular, and I think eggs might be a half decent source of vitamin D3. And I believe this form of vitamin D, cholecalciferol, that comes, this dietary form, is said to be more easily utilized in the human body than the other form of vitamin D that we can get from our diet. This other form of vitamin D that we can consume is called actually the scientific word for it is ergocalciferol, or vitamin D2, more usually known as. So vitamin D2, you can get this from certain plants, non-meat foods, but most of the time, I believe most of the vitamin D2 that people ingest is synthetically produced. So most notably, when you see foods that are fortified with vitamin D, that food is usually fortified with vitamin D2. And that vitamin D2, by the way, is usually synthetically created. So usually you find it in milks, breakfast cereals, breads, things like that. That is when you see something that's been fortified with vitamin D, it's usually, I think it's almost always vitamin D2. So that's that. Once vitamin D2 and vitamin D3 enter the bloodstream, so once we ingest whichever of these forms of vitamin D2 or D3, it gets into our bloodstream rather than going through the other route. It gets into our bloodstream through the intestinal tract. So we eat it, and then the intestines, it enters the bloodstream via the intestines. And again, it's connected to the DBP, which is the vitamin D binding protein. So those are the two ways that we can get vitamin D: from sunshine, synthesizing it in our skin from the sun, or we can ingest it. And again, the two forms, vitamin D3, we can only, the one that we synthesize in our skin is only vitamin D3. We can get through dietary means vitamin D3 from animal sources, but also we can get vitamin D2 from non-animal sources and from supplements and fortified foods and that sort of stuff. So that's the kind of first stage of vitamin D metabolism. Then there's another phase. So there's another stage. So vitamin D goes through various stages, several stages of metabolization, or metabolism, I think is the correct word. Once vitamin D2 and vitamin D3 are in the bloodstream, so that again, to say again, cholecalciferol, which is D3, and ergocalciferol, which is D2. Once they're in the bloodstream, they go through several stages known as hydroxylation. So first of all, they are transported to the liver by the vitamin D binding protein. The vitamin D binding protein is like a car for these things, or I don't know, a skateboard or something that these vitamin D compounds must use to get around in the bloodstream. So they go to the liver, and once they're in the liver, another protein known as an enzyme hydroxylates them and transforms them into what is the major circulating form of vitamin D, which is known, the long name for it is 25-hydroxyvitamin D. It's also known as Calcidiol, or I think another term for it is Calcifediol or Calcifediol, one of those two. This compound is the vitamin D that when you have a vitamin D test, when you go to find out how much vitamin D you've got circulating in your body, that is what is going to be measured, the Calcidiol, or 25-hydroxyvitamin D. And I just want to say this, the current scientific consensus seems to be, from the reading I've done, seems to be that this Calcidiol is in and of itself biologically inactive. In other words, it doesn't do anything. It has to go through another stage in order for the body to do something with it. But there are some dissenting voices who argue otherwise, and this is something I'm really keen to read into. Because the reason I'm keen to read into this is because when you look at ethnicity and when you compare the levels of this Calcidiol, 25-hydroxyvitamin D, you find that Black people tend to have lower level. Black people, to give you a sneak preview of our next session on vitamin D deficiency, dark-skinned Black people tend to have lower levels of this overall circulating vitamin D than other people, most other people, not all, but most other people. And I'm keen to sort of understand that in a little bit more detail. I've got a good working understanding about that, but it seems that we have the same levels of the next stage of vitamin D, which is considered to be the bioavailable stage of vitamin D. However, I think it wouldn't surprise me if the circulating vitamin D is actually biologically active in some way and does have an impact on health outcomes and so forth. But we will talk about that next week. But let me just read briefly from this one of these papers that I've gone through, which this paper argues that there is a function for Calcidiol. It says this: in addition to being a precursor for its active hormonal form, for its endocrine and autocrine functions, 25-hydroxyvitamin D also has independent physiological effects in the body. Based on emerging data from the laboratory, clinical trials, and data on circulating 25-hydroxyvitamin D levels during the past few years, it is likely that for the optimal functioning of these systems, significant amounts of vitamin D should be available on a daily basis for a longer duration to ensure stable circulating concentrations and its health benefits. And I've got a link to that. I'll put a link to this. I just want to say as well, I'm going to share all my notes for all of these sessions that we do. If you could just sign up, please sign up at eliwananda.substack.com and sign up for the free level for the sign-ups, and I'll send the notes for this along with a transcript of this video as well, so you can have all of the references that I've looked at and you can start your own study as well. But anyway, we're going to come back to that again in a future video, but in a future session about vitamin D deficiency. But I just wanted to put that out there that although most people seem to say that this Calcidiol is inactive, there are some dissenting voices about that. But everyone agrees that most of this Calcidiol is taken to the kidney by the vitamin D binding protein and undergoes one last hydroxylation, which is a type of metabolism. It's a step in metabolism, basically metabolizing, substances so that we can use it. So this Calcidiol goes through one last hydroxylation in the kidney, and this transforms it into what is known as 1,25 dihydroxyvitamin D, also known as Calcitriol. So this Calcitriol is the active hormonal form of vitamin D. And again, this Calcitriol is considered a hormone. It's now a hormone because it gets attached to, once it comes out of the kidney, and it attaches itself to, or it's attached to binding proteins, and then it's transported to cells, mainly in the skeletal and muscular tissues, in order to carry out its work relating to bone health. So again, this active form of vitamin D is known as Calcitriol, or 1,25 dihydroxyvitamin D. Now, let me share this slide with you, because I've been really fascinated, because most of the time that is where it stops. Most of the time, when you read the scientific literature, they just say that. They just say, oh yeah, that's it. So all the vitamin D goes into the kidney, and then it's used in the kidney and rare. So, but this is the kind of image that you will basically usually be presented with. So we've gone through all of these stages already. So you see, there's two sides, two ways in which we can get a vitamin D. It can come on the left-hand side there. You can see it can either come through from the sun. It's synthesized in the skin, and then it gets turned into. In fact, it's fun. It gets turned into vitamin D3, Calciferol, you can say, in the middle, and it goes into the blood there, into that blood vessel. Or it can come there, if you look on the right-hand side, we can eat it, and then it goes through our intestines there, and that can be either cholecalciferol, vitamin D3, or ergocalciferol, which is vitamin D2, and that also ends up in the blood vessel, in the blood, attached to vitamin D binding protein. Then it's hydroxylized, if that's the right term, in the liver, first and foremost. And in the liver, it gets turned into the major circulating form of vitamin D, which is known as Calcifediol or Calcidiol, or 25-hydroxyvitamin D. And usually, this is the way that it's usually presented, is that it then goes down into the kidney there. That's a picture of a kidney right there in the middle at the bottom. And then it is turned into the active form of vitamin D, which is Calcitriol, and that's it. Bob's your uncle, as we say in the UK. However, there is an important thing to say here. I've been reading the work of a researcher called Sunil Wimalawansa, who I believe is a Sri Lankan researcher, very prolific. He's got a lot of papers you can find on vitamin D, and he made a point in one of his lectures that I listened to, which is really important. He made a point that circulating this Calcidiol here, not all of it ends up going into the kidney. And what he actually says is that so vitamin D has effects on the bone, like I said, on the bones and on calcium levels and so on. And to me, it seems like that is what everybody focuses on usually, because that's the major purpose of vitamin D. When it was first discovered, that's what people, that's what it was shown to do, and that's what people kind of focus on predominantly. And it's kind of considered to be like that is the purpose of vitamin D, is making sure that we have healthy bones, and it is a key it is a key function, of course, of vitamin D. However, this Wimalawansa points out that vitamin D has extra skeletal functions, actually. Vitamin D doesn't just work on our bones, doesn't just work on regulating calcium levels. So this is we'll come on to that in a minute, but it doesn't just do that. It also operates on various other parts of the body. And what he shared a really good slide here, which I'm going to share to, where are we here? He pointed out that actually, let's share this. This is what it really should look like. So you've got the yes at the top, yeah, you can come through the sun or diet or supplements, and goes through the skin, yeah, goes through the liver, yeah. Then you've got this circulating Calcidiol or 25 hydroxyvitamin D. What he does here, which I think is brilliant and has opened my eyes to understanding how complicated and how powerful this whole vitamin D compound family is. You've got two things that it can do once it's turned into Calcidiol. It can go here into the home, it can go to the kidney. So renal means related to the kidney. Yes, it can go there, and it creates, it can be transformed into the hormonal version of Calcitriol. Then it's secreted into circulation like other hormones are, and it regulates calcium homeostasis, which is make sure that calcium levels are right. Bone mineralization and parathyroid functions, and it acts on parathyroid cells and the musculoskeletal system. So these are the hormonal, what he calls the hormonal functions. And again, I'll have a link to all of these sources in my show notes, which I will share if you just sign up at eliwananda.substack.com. But then he says that he points out that there's a non-hormonal route. So what can happen is that you have this circulating Calcidiol that can be taken directly into certain cells, and he focuses predominantly on the immune system. And it goes to those cells, and in those cells, not in the kidney, not in the renal system, but in those cells, it's there then turned into Calcitriol. And he calls it non-hormonal Calcitriol because the Calcitriol hasn't circulated around the blood like it did when it was hydroxylized in the kidney. Rather, it was Calcidiol that circulated in the blood, went into a cell, and then was transformed into Calcitriol, the hormone. And this hormone has autocrine and paracrine functions, which means that it can change the cell itself, and it can influence the cell to change other cells. Just fascinating stuff. This whole internal universe in our bodies is just so fascinating for me anyway. And what he argues, and we'll go on to this in a minute, is that only this form of Calcitriol can have an impact on our immune system, on our immune tissue, on our immune cells. Only this form. So when we're talking about vitamin D, he argues that it's very important to have good high levels of this circulating Calcidiol in order that our immune system and other systems have enough raw material or substrate to transform into Calcitriol in order to do the non-hormonal functions, if that all makes sense. So really important to understand that vitamin D is not only the Calcitriol 125 dihydroxyvitamin D is not only synthesized or created in the kidney, where it goes on to do the work around the bones and calcium levels. It is also generated directly in cells outside of the kidney, and that relates to the immune system in particular. So there we go. All right, so this is that point I just made there and went on and on and on about. That is going to become important if you do watch the next session that we do, where we're going to talk about vitamin D sufficiency and deficiency and so on. That's going to become really important. But what I wanted to just kind of say now, I just wanted to point out now, really, is how many steps we haven't even started talking about we haven't really talked about what vitamin D does. And yet we have seen so many stages, haven't we? So many stages, cholesterol gets turned into this 7-dihydrocholesterol, which then the sun shines on the skin, and then the skin turns it into this pre-vitamin D, and then that gets turned into vitamin D3 and goes into the bloodstream and so on, and then through the dietary form, then there's this hydroxylation in the liver, gets sent into this other form, transformed into this other form, and so on and so on and so on and so forth. And there's so many elements at play here. There are so many proteins and enzymes and compounds and loads and loads of different stages involved in this. And the thing, I think one thing to remember as well is the signaling mechanisms, receptors, cells, organs, body tissues, this, that, and the other. All of these as well under the control of various genes. I haven't talked about any of the genes because I don't want us to be here all night kind of getting into it. But, that's important to understand as well, is that the body is a fantastic thing. It's a miraculous thing. And, diet is really, really important to make sure that we're feeding all of the things that are going to make all of these functions and processes work as best as they can work, So, what does vitamin D do anyway? Now, this is the kind of the main section of of our session today. What does vitamin do? What's the point of vitamin D? It goes through all these stages. Wonderful, fantastic. But what for? What does vitamin D do? This is an important point, and this is where the mind is pretty blown, or my mind is pretty blown anyway. So what I wanted to do is just show you this image here, which lists a bunch of the different compounds which are labeled as vitamin D. Where is it now? Yeah, there we go. So hopefully you can see this now. These are some of the not all of them actually, but it's some of the compounds which come under the family tree of vitamin D, as I like to think about it. And what you'll notice here, look at the names. All of the names, if you look at them, have got cal in them. Ergocalciferol, cholecalciferol, dihydroergocalciferol, sitacalciferol. Then you've got, he hasn't even listed them here. Then you've got, of course, we've talked about calcitriol and Calcidiol and Calcifediol, and there's probably other ones as well. Loads of different forms of vitamin D, all got this cal term in there. And you know what the reason that they've got, I think the reason why they've all got that cal form in there is because, like I said, the attention on vitamin D has been all about the role it plays in regulating our vitamin D, regulating our calcium levels in the body. And when vitamin D was first discovered, or if you want to call it that, in the early part of the 20th century, that was the revolutionary impact that it had, or maybe even before then as well. But because before then, there was a lot of problems when the Industrial Revolution happened in the West. There were a lot of problems with people's bones, because they were living in smog-filled cities, and probably their diets were awful, probably not out in the sun much, and so on and so forth, because of the new industrialized machine order. And so there was a lot of rickets. Rickets is where your bones are soft and get mangled and all that sort of stuff, particularly in children. Rickets is in children. So vitamin D was discovered, quote unquote, and then they realized that it had an effect on calcium levels. So vitamin D is one of the main purposes that vitamin D has. And again, this is the vitamin D that comes from the kidney, that is hydroxylized in the kidney, is to regulate the levels of calcium and phosphate in the body, particularly in the bones, the skeletal system, which is essential for promoting and maintaining optimum bone strength and bone health. So that's the first kind of, they call it, in the literature, they call it the classical function of vitamin D relating to bone health and bone strength. And again, sneak preview for our session next week when we talk about vitamin D deficiency. One of the confusing things, when I did my video in 2013, one of the confusing things was that Black people were said to be vitamin D deficient, but Black people also tend to have stronger bones and much less prone to fractures and all that sort of stuff. So what's that all about? Well, I think I've got an explanation for that now. But that was only a big issue because, generally speaking, people seem to think that vitamin D, back then, certainly, the consensus was vitamin D is just about bone. So that's all they do. However, as we now know, we kind of knew then as well, 10 years ago, but we really know now because there's been an explosion of interest in vitamin D. In the last kind of 3 decades or so, the traditional scientific community, if you want to call it that, has woken up to vitamin D's explosively wide remit. It's estimated that vitamin D affects around something like between 300 and 900 genes in the body, which is about 3% of genes in the body, which apparently is really high for one family of compounds to impact. And one of the things that kind of has pointed the community into this direction is the realization that what are known as vitamin D receptors, i.e. these are what would you call vitamin D receptors? These are keyholes. That's how people usually call it, keyholes. So if you think of the vitamin D as a key, it's floating about in the blood, and then it finds a cell, and if that cell's got a hole in there that fits the key, that's a receptor. So there are a bunch of these vitamin D receptors, or VDRs, and they are found in cells not only in the bones, but spread all in various parts of the human body, which is one of the most obvious indicators that vitamin D has a much wider remit than just focusing on the bones. Peace out to you, Kamjiverse. Nice to have you on board. Salama, karibu. Shout out to everyone else as well who's with us in the chat, quietly watching and learning with me. And so if I share this, let me share this slide here to show you all of the different places, or I don't know if this is all of them, but some of the different places that the vitamin D receptors can be found in the human body. So making it very clear that the vitamin D is not just about them bones, because if you look here, you've got over 230 vitamin D receptors in the nucleus of most tissues. Okay, a nuclear receptor, which I believe means it's in the nucleus of a cell. It regulates gene expression, i.e. turns genes on and off. This thing here, you might or might not be interested to know. This is how it works. The vitamin D is there. It's connected to the vitamin D receptor, and then there's this RXR thing. Anyway, this is how it works in the cell. But more pertinently, on the right here, you can see all the different places where there are vitamin D receptors. Interestingly, here in the, what is that? Is that the ovaries? Prostate. Yeah, you've got kidney, you've got the liver there, you've got the lungs, parathyroid, which is up here, pituitary glands, skin, spinal cord, nasal, oral mucus, teeth, thymus, heart, spleen, adrenal, which we know as kidney, esophagus, stomach, pylorus, small intestine, large intestine, testes, epididymis. What's that? Something deferens. Is that the foreskin even? I think that might be the foreskin. Prostate, in the prostate gland, in bone, and various other places. Vitamin D receptors, that is, are spread all around the body in various different parts of the body. So that was one of the first clues for the scientific community that vitamin D does a lot more than just the bones. And then, so that was an important realization, which has led to a lot of research into, okay, well, what does this vitamin D do? Now, I'm going to finish our session today talking about some of the associations between vitamin D and various diseases, because if vitamin D receptors are in various different parts of the body, then the question, should come up, oh, maybe vitamin D levels, again, talking about deficiency next time round, vitamin D sufficiency and deficiency next time round, maybe vitamin D levels are associated with certain ailments, certain disorders, certain diseases. And there are lots of these associations. One caveat, though, is really, really, really important caveat, which is probably going to keep coming up in all of these sessions that we do on health in particular, but science generally, and just logical thinking, generally speaking, is that correlations don't in and of themselves necessarily prove causation. So just because something is correlated with something else, just because if people who have low vitamin D, for example, are more likely to X, that doesn't necessarily mean that the X, whatever it is, the outcome, it was caused by the low vitamin D or high vitamin D or whatever. Correlation doesn't necessarily imply causation. Is the thing to really understand that. And if you really get that and really impregnate that deeply into your psyche, that just because something correlates with something else doesn't necessarily mean it causes it, the world will make a lot more sense. For example, when you read those articles in newspapers and you see those news stories that, study has shown that people who drink milk are more likely to, get a first-class honors degree at university. If you don't understand that correlation doesn't necessarily imply causation, you'll be bamboozled to think, I better start drinking milk. Maybe I'll get a first in my university degree. But actually, the correlation doesn't necessarily prove that one thing caused the other. Yeah, so it's really important to understand that correlation doesn't necessarily in itself prove causation. However, I would argue that, particularly in the case of vitamin D, the sheer volume of the correlations that we have is in and of it, first and foremost, should tell us that tells the scientific community, okay, well, we need to look a bit closer into this. Can we demonstrate a causal link? And there are some studies which are demonstrating a causal link. Probably the best way when it comes to science, obviously personal experience is the best way. So if you start taking a vitamin D supplement to sort out a particular condition and you find that it sorts out that condition, then that's your answer. And personal experience is critically important, probably more, I would say it's more important than all this scientific stuff, as long as you're not going against like something that's, I don't know, as long as you're not like dosing yourself up on some vitamin that it's been widely established that if you do it over this amount, you're going to kill yourself, or something like that. But generally speaking, your personal experience will tell you, you don't necessarily need to read all this stuff or so on. But there are studies. So one of the best ways of proving a causal link is what's known as randomized control trials or randomized control studies, and my understanding of these is that you take two groups of people, you give one group a substance. Say you want to know about vitamin D. Does it cure cancer or something? You give one group they've both got cancer. These groups have both got cancer. They're both matched by age and gender or whatever. You give one group vitamin D a particular level. You give another group a placebo. Neither group knows which one is. I think the double blind thing is a good thing as well. So neither of the groups know if they're taking the placebo or the vitamin D. And the best thing to do is that neither the people administering them know which one is vitamin D and which one is the placebo. And then over a period of time, you monitor their, the progress of their condition. And if after a certain period of time, you find that, this group had a better outcome with regard to the cancer than this group, the placebo group, then you can safely say that, this suggests that vitamin D does help, alleviate the impact of cancer or whatever. The bigger the study, the better, obviously. And, there's all, reading these studies, you can really see that there's so much nuance and so much detail in there. You have to read studies very closely. Don't just go by the headlines, because you will get misled But that's one. There's a lot of these randomized control trials that are being done, and also there's a lot of in vitro work, which is I think they call it preclinical studies, where they put it under a microscope in a test tube or whatever, and they put vitamin D, and then they've got like a cancer cell or whatever, and they say, look, the vitamin D's killed the cancer cell or whatever. That's that. There's some of that that's coming up as well. But what we're going to do for the last part of this session, we're going to go through some of the evidence from a few different studies that I've read, pointing to the connection between vitamin D and certain diseases. So let's get into it. First of all, vitamin D, I think for me, one of the most important or fascinating, I'd say important areas is immunity, is the immune system, because we saw it in the whole thing. I won't say the word, but we saw it in the whole thing from 2020 to now. There was a lot of stuff that was coming out with regard to vitamin D's efficacy in improving outcomes for people who contracted that particular condition. And just generally, I mean, here in the UK, we're entering winter. It's cold as heck. And, people are getting colds and sniffles and so on and so forth. The immune system is everything. The immune system is what defends us from sickness and death, isn't it? So lots of stuff here with regard to the immune system and vitamin D. Quoting from a study here, links, sign up at eliwananda.substack.com and you get all the links. So let me quote this one. There is evidence that vitamin D modulates B for Bravo and T for Tango lymphocyte function. So lymphocytes, I believe, are lymphatic cells in the lymphatic system, which are basically one of our many defenders in the body. And vitamin D deficiency has been associated with conditions such as multiple sclerosis, type 1 diabetes, rheumatoid arthritis, systemic lupus erythematosus, dermatomyositis, inflammatory bowel disease, hepatitis, asthma, and respiratory infections. And then just to read in a little bit more detail about some of those, the ones that kind of jumped out at me. So one of them is hepatitis. So we read, data suggest deleterious, i.e. bad, effects of vitamin D deficiency on the course of chronic hepatitis B and C infections, with some studies suggesting a possible role and mechanism for vitamin D supplementation in improving outcomes in these patients. Asthma. Data suggest that vitamin D may have an effect in reducing the risk for respiratory infections in children, with more pronounced effects after 5 years of age and in those that are vitamin D deficient. And I just want to say, Black children, the vast majority of Black children are vitamin D deficient. So this is of extreme importance to us. Actually, all these. One of the things I'm seeing is that the effects of vitamin D tend to be particularly beneficial for those who have low vitamin D levels. We have low vitamin D levels. But anyway, this may explain the reduced risk of asthma exacerbations in children with vitamin D supplementation, although asthma severity does not appear to improve with vitamin D. The mechanism underlying the effect on respiratory infections needs to be determined, but may involve the impact of vitamin D on inflammatory pathways. Then another quote from a different paper here on continuing on respiratory infections. Numerous clinical studies have revealed associations between vitamin D deficiency and increased risk of infections, particularly of the upper respiratory tract. Correlations between vitamin D deficiency and tuberculosis susceptibility were made in the 1980s, as was the observation that 125 dihydroxyvitamin D, so Calcitriol, inhibits the growth of Mycobacterium tuberculosis in cultured human macrophages. Since then, many preclinical and clinical studies have investigated the potential of vitamin D supplementation to prevent or treat tuberculosis. Apart from TB, tuberculosis, multiple randomized control trials have provided evidence for vitamin D supplementation of deficient populations in preventing infections. And it gives an example here. A highly publicized trial published in 2010 concluded that vitamin D supplementation reduced the risk of seasonal influenza infections in Japanese children, with the effect being most pronounced in children who had not been previously supplemented. Other studies have provided evidence for the benefit of supplementation in populations at elevated risk of upper respiratory tract or ear infections due to vitamin D deficiency or a history of recurrent infections. That's quite interesting, personally, actually. However, results of such trials are not unanimous, and that's something to, I know some people might want to just watch some of these videos and be like, oh yeah, vitamin D cures everything, and it's been proven. It hasn't necessarily been proven, and I like to read go directly to the scientific literature, because these people tend to tell it like it is. They might spin it a little bit in their abstracts, but when you read the studies, they will usually say, okay, there's weaknesses with this study, some gaps here and so forth. So, it's not about going gung-ho with all of these things and just pretending that something is a panacea, because, but like I said, there's enough there for me to, particularly that point about, children who get recurring infections, particularly ear infections. That's really, really interesting that supplementation has been, it's been shown in some studies that it may help. And just on that point as well, we'll talk about this. I'll talk about this in more detail, I think, in a future session about supplementation, whether to or not, and how much, and so forth. But one of the things I've seen in some of these studies is that the volume or the size of the dose is quite important, and also the length of time that dose is being given. Some studies, they'll say, oh, we gave them 500 UIs of vitamin D a day and nothing happened. It's like, well, 500 UIs is nothing. Is a very, very low amount, particularly for adults, whereas if, there's a study that's given, in the thousands of UIs, 4, 5, 6, 7, 8, 9,000 of UIs daily, that's where you're looking more, So anyway, lots of nuance in all of these things. Let's move on to autoimmune diseases. Observational data, these are correlation studies, have consistently confirmed an association between poor vitamin D status and all major autoimmune diseases. Topical 125 dihydroxyvitamin D, or its analogues, have demonstrated efficacy against psoriasis, which is characterized by increased keratinocyte proliferation, but has inflammatory and autoimmune components also. The relationship between vitamin D deficiency and multiple sclerosis, again, has also attracted extensive interest. There is broad and growing evidence that vitamin D receptors and vitamin D metabolic enzymes are present in the innate and adaptive arms of the immune system, and more significantly, that vitamin D signaling in the immune system is physiologically important and of clinical significance in patients with deficiencies. Overall, the data suggest a role of vitamin D status in sensitivity to infections and autoimmune diseases. All right, that's a summary of what we said already. Then just looking at a few more here, you've got obesity. What's about obesity and vitamin D? Vitamin D deficiency has been associated with obesity in both pediatric and adult populations. The prevalence of vitamin D deficiency is about 50% in children with obesity, and attributable to decreased sun exposure, secondary to low activity level, poor nutrition with decreased consumption of vitamin D containing foods such as milk, as well as storage in adipose tissue. That last point there is an important one, because, and again, this is something for future we'll do in future, but I understand that people who are overweight or obese, the vitamin D doesn't get to where it needs to get to, because vitamin D is a fat soluble family of compounds, meaning it can only be dissolved in fat, and it is very lipid happy. It wants to be in fat, basically, and so it seems that if it's in the bloodstream, it will more likely than not get sequestered into fat, and if it's in the fat tissue, then it's my understanding is that it can't be used if it's in the fat tissue. So that's like a risk factor for being able to adequately utilize vitamin D, is actually obesity and overweight. And that is going to be important in our next session, because one of the things that explains the surprising differences in vitamin D sufficiency between African people and South Asians is body fat percentage. I'll just drop that there. Because you might expect that Africans would have lower vitamin D levels on average than South Asians, but they don't, and it's all to do with body fat percentage. So moving on, colon cancer. Meta-analyses. This meta-analysis is a study of a bunch of studies. It's a study of studies. They get a load of studies and say, right, we're going to look at all the studies that have been done on this topic and synthesize the findings into a consensus. Meta-analyses have reported inverse associations of 25 hydroxyvitamin D levels and vitamin D intake with the incidence and recurrence of colorectal adenoma. One meta-analysis suggested a 10 to 20% reduction in risk of incidence or recurrence of colorectal adenomas with every 20 nanograms per milliliter increase in 25 hydroxyvitamin D levels. That's Calcidiol. Another meta-analysis suggested a 26% reduction in risk with every 10 nanograms per milliliter increase in Calcidiol levels. So it could be that the more vitamin D that you have in your circulating in your blood, the less likely you are to get colon cancer, potentially. But that would need to be, causation would need to be proven there. That's just correlation. Muscle health, it goes without saying, observational data suggests that severe long-standing vitamin D deficiency is associated with muscle weakness and cardiomyopathy in infants. How many more we got here? There's a load. Oh, no, 3 more here. Cardiovascular health. Human observational data also link a poor vitamin D status with several cardiovascular risk functions, including all aspects of the metabolic syndrome and cardiovascular events and even mortality. Now, that one right there, this metabolic syndrome, my understanding of metabolic syndrome is that it's comprised of high blood pressure, hypertension, high cholesterol, bad cholesterol in the blood, and what's the other one? I think the other one might be obesity. Anyway, that's metabolic syndrome. There's like 5 things. If you have 3 of them, they say you have metabolic syndrome, and I think diabetes might be involved in there. And anyway, all of these things are, oh, it actually says it a bit later on there. All of these things are particularly high amongst African populations in the West. So we need to pay close attention to this. So a caveat here from this study, it says intervention studies, however, so intervention studies are when you give people supplements and see if it fixes the thing. Intervention studies, however, so far are equivocal, and this may be due to a lack of causality or due to poor design of the randomized controlled trials. A minimal effect of vitamin D supplementation of vitamin D deficient subjects on systolic blood pressure is plausible. The causal nature of associations between vitamin D and cardiovascular disease remains uncertain. Whether the association differs across patient populations, i.e. different sexes, racial and ethnic groups, chronic kidney disease, diabetes, etc., also needs to be explored. So there's association, there's correlation there between low vitamin D status and cardiovascular issues. Cardiovascular is to do with the blood, the blood pumping around the body. But the causality hasn't been established as yet. And this is 2019. This study was written. Multiple sclerosis, we said it already, but I'll say it again. Low serum 25 hydroxyvitamin D concentrations have been found in patients suffering from a variety of neurologic diseases, such as Parkinson's disease, Alzheimer's disease, or schizophrenia. Apart from multiple sclerosis, which we discussed already, and then MR studies, just so you know, are I think it's Mendelian randomization. And this is an emerging field where they basically look at people's genes and see if those genes are correlated with certain certain diseases, and whether those genes are correlated, in this case with vitamin D. And it says, MR studies found clear links between vitamin D status and multiple sclerosis, and also with Alzheimer's disease. So there's potential there to show that there is vitamin D is somehow modulated by genes that in a way that it has an effect on these things. In the latter study, dealing with 17,008 cases and 37,154 controls, one standard deviation lower predicted that serum vitamin D, let's just say, caused a significant 1.25-fold higher risk of Alzheimer's disease. Two other MR trials did not find a link with schizophrenia or Parkinson's disease. So it seems like the link between vitamin D and Alzheimer's appears to be stronger there than some of the other ones. And then the last section here I'm going to read is a good summary, actually. The last section here is about all-cause mortality and longevity. And it's a good summary. I'll just read it. It says, if low vitamin D status has such broad-ranging effects on so many extraskeletal tissues as described above, it would certainly increase the risk of a variety of diseases and thus ultimately increase mortality risks. No preclinical data exists on the relationship between longevity and vitamin D status. Many observational studies, as described above, associate a poor vitamin D status with nearly all major human diseases. It's important to note that there. That means that almost all major human diseases are more likely to happen with people with low vitamin D status levels. And therefore, it would not be surprising that a poor vitamin D status would be associated with an increased mortality risk. Indeed, most observational studies found higher mortality rates in persons with the lowest vitamin D quartiles or quintiles in European and US populations, with the highest mortality rates found in subjects with serum vitamin D levels of 50 to 60 nanomoles per liter. And let me just say, I'll talk about this next week, but I'll finish it. A meta-analysis of 8 prospective studies on more than 2,600 participants aged 50 to 79 demonstrated a consistently higher overall mortality rate with participants in the lowest serum vitamin D concentrations, usually well below 50 nanomoles per liter. And that's the end of that quote and the end of my quotes from these various studies. And I was going to say that the last time I did I think I've only had my vitamin D levels checked once. And when I had my vitamin D levels checked, my levels were at 20 nanomoles per liter. So they're talking here about, less than 50 being associated with higher mortality rates. Mine was like half that. So this is serious and very personally relevant stuff for me. So to conclude our session today, vitamin D is a family of compounds that play a role in a wide range of bodily functions. These functions are still being studied, but in my opinion, there's more than enough there. And I've just scratched the surface a little bit with some of these quotes here. There's more than enough there to demonstrate that vitamin D is a critical nutrient for our health and well-being. And so, that's where I'll finish up by saying that this is the reason why I'm studying vitamin D, and this is the reason why I'm going to share about vitamin D in coming sessions, because it's very evident to me that vitamin D is a key to life. Basically, it sounds overblown, but I just feel like it basically is a very obvious key to life that has and that will have massive ramifications as far as as far as lifestyle, as far as on an individual level, as far as how we live our lives, getting out in the sun and so forth, where we live. If we were able to move to different parts of the world, maybe consider living somewhere sunnier where you can get more vitamin D the best way, which is from the sun. But also it has ramifications with regard to supplementation decisions. I would argue that of all the vitamins and minerals and whatnots that I've studied in any depth, vitamin D is by far and away the one that has the strongest case for me personally. This is not health advice to you, for me personally and my family, it is the one that has the strongest case for supplementation. And I'm going to go into that in more detail in future videos. So much appreciated to everyone who's joined us today. Thank you so much. Do sign up at eliwananda.substack.com so that you can get the show notes emailed to you, and with all the references of the studies that I've looked at today. We'll be back hopefully next week, middle of next week as well, similar time, to talk about vitamin D deficiency or insufficiency or sufficiency, and to talk a little bit in particular with a particular focus on ethnicity, with a particular focus on African people, to talk about, are we vitamin D deficient? Is that true or not? And what impact, if any, does that have on our health vis-a-vis the health of other people? And are there, are we looking at, I've talked about this in a post, are we looking at that in twofold? Are we looking at the diaspora, vitamin D levels in the diaspora, comparing it with vitamin D levels in the continent, talking a little bit about how, what impact all of this has on our health and well-being. So much appreciated to each and every single one of you. Thank you for watching. If you're watching this on the replay, thank you for watching. Make sure you subscribe to the video. Make sure you like and share. And I will be back this weekend as well. We're reading a book called Blueprint for Black Power by Baba Amos Wilson. So we'll be doing that, I believe, on this coming Sunday, 9 p.m. UK time, 3 p.m. Eastern Standard Time. But for now, I want to say peace, stay well, stay blessed, and see you soon.